Yay! Hi, everyone. Welcome. Welcome to this presentation about the ETH contract API. So I'm going to explain what you can do with it. And I organized this presentation by having some keywords and to explain like the spirit and what does it mean with this library. For example, the integration. So I started this library because I wanted to use smart contracts in my Java application, and it was really hard to do. So Ethereum.js was there, it was really nice, it worked, but the API wasn't as user-friendly as I hoped. So I started to work with that. And then I thought, okay, how do I want to integrate my smart contract in my application? So I thought, let's have an interface that represents it, and just do the binding and work with the smart contract as if it was any other service. So that's what I've done. So you can link it by having the source code or the ABI. And then you have all the data conversion so that you don't have to work with uint and this kind of stuff, but you can actually work with Java types or any JVM. If you're on Scala, you can do that with Scala types or Kotlin types or whatever you want to do. And because we're in the typed world, I'm trying to have types for everything that's going on Ethereum, like some Ether value, so the Ether account, addresses, source code, ABI, so on and so forth, and not working only with byte arrays and strings like we have a lot of times. So I'm going to show a little bit of code just to explain a little bit more concretely what does it mean. Okay, so the idea is to have an abstract view of Ethereum and work with it. So here you have, for example, a private Ethereum that you will run so that it mines locally so you can play with it and deploy your stuff and have fun. So the way you init the thing is that you have to get your account. For example, here it's just with a string, like in this Brain wallet, but you can also read from a key store. Then you create your Ethereum facade. In this case, I have a private network, so I can configure it to have like some initial balance so that I can actually do something, because without Ether, I can't do much. And then I'm going to either publish a contract or use it. So the way you publish a contract is, first you have to read the source. Here I read from a Solidity .sol file, and then you publish it by saying, okay, this is the publisher, this is the contract information, and because I'm using the source, I have to give the contract name, because there can be more than one contract. And then I get a future of a ETH address, because as you all know, we have to mine the contract to have it deployed. And as soon as you get the address back, then you can link it, like bind it, sorry. So the way you bind it is simply by giving still either from the source the contract and the contract name, but you can also give simply the ABI source, the address. Still, you want to know which account you're working with, and then an interface. And the interface looks very simple, like something like that. And the rule is, if it's a completable future, it means that you're going to create a transaction, and then in the background, it will sync with it. You don't have to take care of synchronization, waiting for your transaction and everything. Everything is done in the background. And if it's a type that is not completable future, then it will be a constant call. And as you can see here, you do some conversions. So my return type, it will use the constructor to recreate the value from the return value. You can use enum, you can use a normal integer, string, so on and so forth. And then you use it in your code as if it was any other service. So you have your contract, and you call your function, and you get your values back. You can wait for it to be synced or not. It will take care of everything. You don't have to really handle all the Ethereum specialities like the nonce and this kind of stuff. So that's the main idea. Okay. So that was about integration and why it was really important to have a way to integrate your smart contract into Java. And as I showed before, it's also about backend abstraction. I think that sometimes we want to have a node locally, sometimes we want to use RPC, and we don't want necessarily to write again the entire application because you just change your backend. So the way is to abstract it away, and you can simply change. Right now I'm working on mainnet, or I'm working with Web3j RPC, or even a standalone blockchain where you can do your unit tests or integration tests. And this way, you can really concentrate on the business logic of it, like the idea of it, and not really with the technicalities of what's a transaction, how do you encrypt it, and so on and so forth. Another really important aspect is testing. So I have here two main ideas that are, first, the unit testing with the standalone blockchain, so that you can have really fast testings and that you can check your smart contracts, make sure that you don't break anything, that the logic is correct, and so on and so forth. And then some integration tests with a private miner, so that you can have a private node locally, play with it, see if it plays well, and have your scenarios played in your test suites. And the whole idea of this project is to create an ecosystem around that. So kind of a lamp for Ethereum. Because I think that more people need to start building apps and dApps, and it's still the barrier of entry is pretty high, and some people think it's too complicated for them. So we have to help them jump in the ship and have fun with us. And also, basically, more people have to be in contact with the technology. I don't think that you need to write a decentralized application to work with Ethereum. And it will bring to my idea of what I want to do this hackathon, and I hope that people will join me, is that sometimes you have simply an application that is not a decentralized one, but you still want to distribute it, and you want to distribute it to everyone. You don't have the infrastructure, you don't have the money to do that to millions of people, so having distributed systems to distribute your application is really nice. So my idea for this hackathon would be to have a 100% distributed app store with Ethereum and some other cool stuff that I know some other people will present here. So my idea already is to use Ethereum to store application registry and checksum. So the idea is to make sure that when you download an application, it is the application you wanted to download. Nobody tampered with it, nobody put backdoors or anything. This idea is, especially when I heard about Bitcoin, that they were a bit scared that people would tamper their binaries on their website, so that would be a way to make sure that it wouldn't happen. Then use IPFS, BitTorrents, any distributed system to distribute the binaries, to distribute the information so that it scales organically. You don't have to buy servers or buy instances because suddenly you are more popular. There is a need of search engine, but I'm open to suggestions. I'm still not sure exactly how I would like to do that. I know that we have OrbitDB here. It would be really interesting to hear about that. And other cool stuff. I'm sure that we can find out a lot of cool stuff to do here, a lot of use cases, applications to do with this idea. Yeah, so that's my really quick presentation of the library. I think it makes more sense to sit down afterwards and really present the library together and discuss if you have a concrete idea what you want to do, to see together if this can help you and how it can help you, and maybe even to join me to try this launchette, this distributed app stores that we can build together. I don't know if you have already questions or remarks, because I know we have some time.
I don't know if you mentioned, but do you know that as a new feature in and solidity to actually embed content hash for the info into the contract.
You mean the swarm?
Well, it doesn't necessarily have to be swarm.
Yeah, but the way to link the source to the.
Yeah, basically linking the contract info into the. So it's something that you can directly access from the contract info from the bytecode that exists on the blockchain, which means that there's like a direct route to like verify contract source code to maybe automatically run tests if you just point to an address. So there's a lot of possibilities there.
I heard about it. I never tried it yet, but would be really interesting.
It's not even really.
Ah, okay, so.
It's just a PI.
Okay. So yeah, I heard about it. Would it be possible then to just, because the way I did the binding here is that you have to get the ABI from somewhere. Would it be possible to just give an address and then it will download the source and then
So the
inferred?
API is embedded in that contract information. So if you have an IPFS or a swarm hash or whatever you want, or even like a would URL or Roon, then you can just look it up and just that gives you the JSON and one field is the API, so you can directly
Okay.
just knowing the address. So
Okay, that would be really cool because then you can simply give an address. You don't have to give ABIs or anything.
yeah.
Cool.
And I really like this idea to become not a standard in the sense of standard, but it's kind of as a code quality standard in the sense that people should expect non-dApps to have such contract info associated, and it should always people should always treat with suspicion contracts that don't
Publish that.
have transparency like this.
Yeah, thank you. Now, would be really interested to play with it when it's released.
I think it's nice.
Cool.
Maybe not related to your presentation, but for the people here, so I don't know if everybody has already Wi-Fi. So we have here on the left and on the front, we have two access points with the passwords, and we have here also the agenda. We're just going to look up so how we plan roughly the day-to-day.
So, how do you exactly connect to the node? I mean, are you using an RPC interface or is it based on Ethereum J?
So both of them. So the thing is that I started with Ethereum J. So you use Ethereum J as a node to connect to your network, and then I've embedded the configuration so that you don't have to configure it every time for mainnet or any testnet. And then there is this new project, Web3J. There is an RPC interface for the RPC network, like for RPC interface in Ethereum. And then you can use that to connect. So you can either use an RPC backend or an embedded one.
Okay, so it's not based anymore on Ethereum J, right?
Not only.
Okay.
I mean, I'm still using it heavily, especially to sign the transactions and everything.
Essentially, you're using Ethereum J internally, and you're providing a higher level interface.
Yes. Yes. And I'm still a bit struggling with the interface itself because I see some discrepancies between RPC and having it embedded because some information are not there anymore, especially the return value and this kind of stuff. But otherwise, yes, the idea is that you shouldn't feel the difference between being on an RPC or being with the embedded one. Okay. So thank you very much. I hope you liked it. I hope you are going to come and do some awesome stuff with that. Looking forward to see what people have in mind and what people want to do with this kind of technology, and see you afterwards.